Hi, good morning. Welcome to the third edition of the Programmer Robot Competition, this year inside the International Conference on Intelligence, Robots and Systems. This is a competition aimed to foster the development in robotics and computer vision. And it's one of the novelties this year is that it's fully online. We have developed a software infrastructure where students and participants from all the parts of the world can develop robotics code inside. And in particular, we proposed two challenges for this edition, and they were fully developed by participants using the online webpage. In this competition, the solution to the two proposed challenges lie in programming a Python code for a drone. There are two challenges. The first one is just to program a drone inside a hangar, just to go out from the hangar. Inside the hangar, there are moving obstacles that put the things a little bit more tricky than an empty space. So this is a new challenge for this year, and it has been included as a demo challenge. The second one is also about drone programming. In this second challenge, the participants has to program a drone just to look for another drone and push that drone through the 3D space. It's just the cat and mouse game, but using robots. One of them is fully autonomous, is provided by the organization, is the mouse, and the other one depends on the participant's code. They have to program that drone in order to detect the mouse drone and go after it. Another feature of this year edition is that we use gazebo simulator. The participants just enter into the web page and then program on Python using Jupyter, and at the same time a gazebo instance is run on the web server. Well, let's go with the first challenge, the demo challenge. This is the exercise. The proposed problem is just to program this robot, just this drone, just to go outside the hangar where it's lying. Just going, the door is just on the left side, and it has to surpass different mobile objects, like the moving walls over there. We've got a blue wall and a red one, just moving, just to put the things more tricky to the student. The drone has a camera on board and has several motors also, so they are always accessible to the student's code through the motors functions and through the get image function. Here you can see the theory. This is the side from the drone point of view. At the beginning, we can see here the output door, and the challenge is just to command the robot to go through the hangar, avoiding the collisions. So here we have the cell codes here with the solution from one of the participants, is Carlos Guadalajara. So here is the image from the drone camera right now. So it has stopped in order to avoid the collision with the blue wall. Then it sees empty space and then goes up just to avoid the collision with the red one, and finally exit successfully the hangar. So this is the demo challenge of this competition. Well, so once we have seen the first challenge, we are ready to the competition itself, to the finals. So we have three participants at the finals. This one so far from different parts of the world. Just a few words, just to present the sponsors that they have helped to the development of the championship: Deloitte, Universidad de Juan Carlos, and JdeRobot Open Project. So in this second challenge, The proposed problem is just to program a cat drone in order to pursue a mouse drone. The drone is exactly the same as is the first challenge. It has a camera on board, it has also a GPS, and it has motors. The development of the competition is divided in 2 rounds. One, testing the participants' code against the Q1 mouse, and the second round with a different mouse. A mouse that moves quicker than Q1 is the name Q2, and it moves quicker and faster in order to avoid the cat. The score is going to be updated in this table, so it depends on the number of seconds that the cat drone is close to the mouse drone. So each round is divided in 2 different stints, just from a starting position against the Q1 mouse, a different starting position with against the same mouse, and the equivalent with the second mouse. So each stint lasts 2 minutes, and the score is just the number of seconds the participant's code achieves that the cat drone is close enough to the mouse drone. So the scores for each stint and each round are already all of them added, and that will be the final score. Here we can see the first participant, Carlos Herranz, and we can see in the screen just the field. The cat drone is the black one, it's running the participant's code, and the mouse is just the red one. It's running an autonomous code provided by the organization, and here we can see just the referee. So we have programmed a referee, an automatic referee, that is measuring on real time. It's measuring the current 3D distance between both drones. The 0 is in the upper part of the image, and each row means 1 meter. So for distances below 4 meters, they are taken into account in this score. That's the Herranz code. It's not very good. It's looking for the mouse. Typically, when the cat drone loses the mouse, it commands look for maneuvers, like rotating itself in order to search for the mouse. The mouse just completes its autonomous route, and the score is going to be very low because just only a few seconds this cat has been close enough to the mouse. In order to do fair comparisons, we just put the participant's code against the same mouse code, and starting from exactly the same initial position. So let's see how the group data code performs. So let's go with qualifying first round. We're going to test now the code from the second participant, the group data. Again, here we can see the referee. So each time the cat is close enough, the background of this referee is green, and in case of being too far from the cat, this referee background is shown in see that the cat drone is doing well. I mean, it has identified the red drone on its images and is controlling its own movements in order to pursue the mouse. So it's scoring very well, you know. So most of the time so far has been close enough to the mouse. So this Q1 mouse is a very simple one. So just with a slow movements, no fast maneuvers. So it goes smoothly through a 3D route. That is the same for all participants. Now it's moving quicker than at the beginning of this stint, but the cat successfully manages to be close enough. Both of them, the cat and the mouse, have the same maximum speed. The group score is doing very well. So no collision has been detected by the referee and almost 1,000 points. This is very, very well. Let's go with the third participant in the finals. And again against the same Q1 mouse. The typical solution here is a set of PID controllers based on vision. So just from the perception, the typical solution just filters the input image based on colors, maybe RGB or HSV. Actually in the simulator, RGB filters are good enough. And from the perception point of view, just to compute the mean average of the colored pixels provides a good estimation about the position of the cat drone in the image. And then depending on the X and the Y, I mean the left, right or upper bottom part of the image where the cat is detected, then the movement of the cat drone can be controlled in a very good fashion. Just for instance, if the mouse drone has been located in the left part of the image, then the cat drone should turn to the left. In order to avoid overfitting of the participant's code to the initial position, we just perform two different stints with different starting positions. So now we are going to put the participant's code against the same Q1 mouse, but now they will start at different positions. The three of them are the same, but different from the first stint. About the perception, just to comment more things about how to solve this challenge. The infrastructure provides a function just to get the image from the drone. In fact, it provides two images, one from the front camera and another one from the ventral camera. The ventral camera is useful only when the cat is looking for the mouse, because usually the most used camera is just the front one. The behavior of the cat here is just to follow, in the first minute, just to follow a 3D route at a very low speed, and in the second minute just follows a different 3D route but in a faster way. So it seems that the JdeRobot's code has lost the mouse and it's looking for it. that search that it's difficult when you don't have an idea of where the mouse is, and when you are far away, because the farther the drones are, fewer pixels appear in the image. Let's go with the second participant. The first one just performed it quite bad in this second stint because it lost the mouse and dedicated most of its movements just to search for it. There are different policies that can be used in order to speed up the search. One strategy is just to use the ventral camera, and another is just to rotate about the vertical axis, so you can see the 360 degrees around, 360 degrees around your drone. As you can see here, the starting positions are different from the first stint. The Brooks code is quite good because as you saw here, his drone just avoided the collision. So that's also a very smart decision. The referee detects collision, and in case of any collision, the participant is disqualified for that round. The drone simulation is quite realistic. We use the gazebo simulator, a very standard one in the research community, robotics research. There the car drone finishes the first part of its movement, and now it starts the second 3D route. Now we are going to see the third participant, how his code performs on the second stint with the first mouse, the Q1. Now from this starting position, the cat drone is far from the mouse drone at the beginning, so it has to move quickly just to reach it. This following behavior is quite good, as you can see here in the referee display. it keeps the drone just around below 3 meters of distance away from the cat mouse and from the mouse drone, and the cat movements are quite smooth, so it seems a good code. It also avoids the collision. You can see there how the drone just avoid bumping into the mouse, and once the mouse resumes its movement for the second 3D route, the cat itself resumes the prosecution. So the scores here are quite similar to the first stint, but they are a little bit lower, maybe because the starting position is farther away from the mouse than in the first stint. So it seems that the last two finalists have the best score. Right? So now we are put the things a little bit more difficult for them, because now the Q2 mouse moves faster than the Q1, so now it's more probable just to miss the mouse for some part of the competition. Let's see. Now the performance depends on the recovery strategies that the participants have already coded. So we will see. Let's go with a runs code. From the outside, the mouse drone seems the same as the first one, but the behavior is completely different, because the 3D route already programmed are different, and because the movements are quicker. So again, this cat seems to have lost the drone. So here we can see just that the cat is almost lost. You know? So it's looking for the mouse, but it seems to search at random, and then it's quite difficult just to identify the mouse run. And so the performance is quite low with this code. It has been close enough to the mouse only in 5 seconds. But by random, not by the intention. So now let's see the second participant's code. It's quite interesting to see how it performs with a quicker mouse. As I said, the red drone is fully autonomous and it moves in a fast way now. This is the real distance in 3D between both of them.
What is the yellow border?
What is the yellow? What do you mean yellow? So they are the shadows. I mean, we have the red one. Oh, that's the point of view. Just in order to change the point of view of the recording camera. That's it. That's it. So there are only 2 drones. Just to change the point of view of the camera. One of them is from India, another one is from Spain. So this is an online competition. Yeah. But anyway, the web is open to new exercises. So there was a call on the robotics worldwide mailing list. quite well because the score is almost not the same as in the first mouse, you know? And for sure this mouse is more difficult to follow than the first one. Wow! Oh, one collision. So in this scene, the points are going to be less than expected. So now let's go with the final stint. We are with the Q2 mouse, a different starting position. This is the position far away. here is the group data, so it has gathered the highest score.